In this video, we're going to do some worked examples using trigonometric ratios and their exact values. Our first question, find the exact value of sine 135 degrees. So, first thing we need to know is 135 degrees is not acute. So we need to determine which quadrant does 135 degree fall. And if we remember our quadrants, do a rough sketch here. And we'll start here is 0. This is your first, this is your second, this is your third, and this is your fourth quadrant. Here is 90 because we're looking in degrees, 180 degrees, and 270 degrees. So our 135 will end up in the second quadrant. Now in the second quadrant, our reference angle is 180 minus 135. So let's do that. So alpha will be equal to 180 minus 135, which is 45 degrees. Now, which one is sine positive, in our second quadrant? If we remember, all ratios are positive here. Sine is the only positive here. Tangent is a positive here. And cosine is a positive here. So sine 135 is positive. So therefore, sine 135 degrees is the same as the sine of 45 degrees. And we know that sine 45 is root 2 on 2. And this is our answer. The exact value of sine 135 degrees is root 2 on 2. Now we have find the exact value of tan negative 135. So if we remember from last week, a negative angle comes as a result of a clockwise rotation instead of an anti-clockwise rotation. So let's put our quadrants up again. If here is 0, then we would have to rotate this way. So this would be negative 90 and negative 135 would be here because up here would make it negative 180. So negative 135 is now in our third quadrant. So is the tangent positive in the third quadrant? Let's recall all, only sine, tangent, then cosine. So tangent is positive. But we need to find out what our reference angle is for negative 135. So if this here is 135 degrees and the reference angle is labeled here red, alpha will be equal to 180 minus 135, as you can see in the diagram. So therefore here our reference angle is also 45 degrees. But we're working in the third quadrant instead of the second, like our last equation. So therefore, tan of negative 135 degrees would be equal to the positive tan because we're in the third quadrant. So tan is also positive of our reference angle, which is 45 degrees. So therefore, this would be the tan of 45 is 1. So therefore, our answer is 1. Our third question, evaluate cosine pi on 2 plus sine 3 pi on 2. So now we are in radians. So let us draw our quadrants again. So this will be 0, this will be pi on 2, this will be pi, and this will be 3 pi on 2. So cosine pi on 2, which we learned a while ago, cosine of pi on 2 is 0. And sine 3 pi on 2, so we have to look again all are positive, only sine is positive, tangent is positive, and cosine is positive. So therefore, the sine of 3 pi on 2 is negative. But negative what? What is our reference angle for pi on 2? If we take, for 3 pi on 2, sorry, if we take 3 pi on 2 to be, we could take it either to be in the third or in the fourth quadrant. Our reference angle for 3 pi on 2 is actually pi on 2, because 3 pi on 2 is 90 degrees away from our x-axis right here, no matter which quadrant we look at, and it is always negative. So sine 3 pi on 2 is negative sine pi on 2. And sine pi on 2 was 1, so this is negative 1. So therefore, cosine pi on 2 plus sine 3 pi on 2 is 0 minus 1, which is negative 1. Now we have this to evaluate the product of tan pi on 4 and cosine pi on 3. So we'll start with tan pi on 4. Both pi on 4 and pi on 3 are both acute angles, so we don't have to determine which quadrant they are. We know that. So we know that the tan of pi on 4 and the cosine of pi on 3 will both be positive. So therefore, we can just recall our exact values from the last video, and that tan of pi on 4 is equal to 1, and the cosine of pi on 3 is equal to 1/2. So therefore the product will be, so the product of tan pi on 4 and cosine pi on 3, we just simply substitute, so that will be 1 times 1/2, and that gives us 1/2. So we have just completed 4 worked examples of questions using our exact values of our ratios. So now let us take the quiz assigned for this week and do some practice as well using our exact values of trig ratios